Hello, I'm Kim Haynes, a product marketing manager in the Chemistry Technology Center at Waters Corporation. Part 5 of this series is a follow-up to our previous module about calculating recovery and matrix effects. In addition to understanding the calculations, it is important to understand how to actually make the solutions and how to set the experiment up on your 96-well solid phase extraction plate or set of cartridges.
I'd like to take a few minutes to explain exactly how we make these solutions to calculate recovery and matrix effects. In my conversations with scientists, I often find that the preparations of these solutions can be confusing, so I think it's helpful to explain them. So first, let's talk about explaining the creation of the post-extracted spike sample. First, we take 500 microliters of blank sample matrix and run that through our solid phase extraction protocol. Our elution step requires that we elute in 50 microliters. Then we take our post-spike solvent and we add 50 microliters of a 100 nanogram per mil solution, equaling a total solution of 5 nanograms per mil. To create the extracted sample, we once again take 500 microliters of sample matrix, but this time it's been spiked with 10 nanograms per mil of analyte. When we run that through our solid phase extraction protocol and elute with 50 microliters, that gives us a solution of 50 microliters that contains 5 nanograms of analyte. So the result is that these two vials both contain matrix components from 500 microliters of matrix that's been eluted with 50 microliters of elution solvent. We've added 50 microliters of post-spike solvent and theoretically have an equivalence to 5 nanograms of analyte in each solution. To calculate matrix effects, we once again need the post-extracted spike sample, and I just explained in recovery how to create that. But here, we also need a standard solution containing the analytes. To create our standard solution, what we need to do is post-spike 50 microliters of our 100 nanogram per mil solution into the sample solvent that matches the elution solution from our post-extracted spike sample. So once again, if our final elution solution is 75% acetonitrile, 25% water, once again, our standard solution that we're spiking into would be 75% acetonitrile and 25% water. There is a special consideration to keep in mind when you're preparing the post-spike solvent. Due to peptide solubility issues or nonspecific binding considerations, it may be helpful to add 50 microliters of stock solution that contains a carrier protein and the organic, such as 80-20 acetonitrile and water with 1% formic acid containing 0.05% rat plasma. So to calculate the matrix effects, effectively we have two vials. Both vials contain 5 nanograms per mil of analyte, which means we've had 50 microliters of elution solvent and 50 microliters of the post-spike solvent. The post-spike sample also contains the compounds extracted from the sample matrix. The other part of calculating recovery and matrix effects that I often find can be confusing to scientists is actually just how to set this up in a 96-well plate or in cartridges. So I'd like to take just a few minutes to talk about that as well. Now, in the calculations, we talked about creating your post-extracted spike sample, your extracted sample, and also your standard solution. So it's important to know where to put these on your 96-well plate and in what order so that you can get accurate results. If you take a look at this diagram of a 96-well plate, you can see how we would set this up. For example, if we focus in on the post-extracted spike sample, or PESS, you can see that we would run our blank sample matrix through the SPE process and then actually spike the standards directly into the collection plate and those wells at the end. And here we do 4 replicates. If we look at the extracted sample, you'll see that we spike our standards directly into that sample matrix before the SPE process and just collect the final eluate into those wells. To create the sample for the standard solution, what we actually do is pipette the final elution solution that's used in the SPE protocol directly into the wells of the collection plate, and then we spike in the standards. There's no SPE actually being performed at all into those wells.
We really hope this module will help prepare you to calculate recovery and matrix effects. For more information about this or other related topics, you can always visit the Bioanalysis Bootcamp to learn more and increase your peptide and protein quantification fitness. Thank you.